Let's take a look at a couple more examples involving standard deviation. So the following are going to be scores of people who took an EMT licensing test. Let's find the standard deviation of these scores. So the scores are 78, 93, 72, 84, 86, and then another 73. The first thing that we need to do is we need to find the mean. So for the mean, we're going to add up all these values and then divide by how many there are. So if we add up all these values, we'd get 486. We divide by how many data values there are, which is 1, 2, 3, 4, 5, 6. So 46 divided by 6 is 81. Now that I have my mean, I need to start finding my deviations to square them. Now you don't necessarily have to organize your data in a table, but I like to just to keep myself organized. So I'll have my data value, we'll find the data value's deviations, and then we will then find the deviations squared. So my data values are going to be 78, 93, 72, 84, 86, and another 73. The first deviation is going to be 78 minus 81, which would give me a deviation of negative 3. Negative 3 squared is positive 9. Second data value is 93, so 93 minus 81 is 12, and then 12 squared is 144. The next data value is 72. 72 minus 81 is going to be negative 9. Negative 9 squared is positive 81. The next deviation was going to be 84 minus 81, or 3. 3 squared is 9. 86 minus 81 is 5. And then 5 squared is 25. And then finally, for the last data value, 73 minus 81 is negative 8. Negative 8 squared is positive 64. For these squared deviations, let's find their sum. So if you were to add up all these values right here, they would sum to 332. So now I can find my standard deviation. The standard deviation S is going to be the square root of this sum, 332, divided by n minus 1. So in this data set, my value for n is 6. So then my denominator right here is going to be 6 minus 1, or 5. So this is what I would want to throw in my calculator, the square root of 332 over 5. So let's pull up the calculator. We're going to do the square root of 332 divided by 5. This gives me a standard deviation of 8.15 if I round to the nearest hundredth. Since that number's 5 or bigger, I'm going to round up right here. So the standard deviation for this would be approximately equal to 8.15. So there's an example of computing the standard deviation by hand from using a data set. In this final example, let's take a look at a bunch of different histograms and see if we can determine which one has which standard deviation. So I have these three summary statistics. So I have a mean and standard deviation so mean of 53, standard deviation of 1.8, mean of 53, standard deviation of 10, and mean of 53, standard deviation of 22. And the question is, which one of these histograms corresponds to which one of these pairs of summary statistics? Now notice all of them have the same mean, so we are then going to look at the spread, or the standard deviation, to try to determine which histogram should correspond to which set of summary statistics. So notice I have a standard deviation that's really, really small, one in kind of the mid-range, and then a standard deviation that's going to be really high. So in terms of these data sets, which one of these would have a standard deviation that's really small? So notice all of these histograms are centered at about 53, right? This one's centered at about 53, this one's centered at about 53, and this one's centered at about 53. So if we start looking at the numbers on the horizontal axis and how that relates to the bars, notice on this last one, the bars go all the way from values below 20 to values in the 120s. None of these other histograms have that same sort of spread on this axis. They don't have that much variability in the data. So in this last histogram, this is going to be the one that's going to have the highest standard deviation. So this one's going to have a mean of 53 and a standard deviation. Maybe let's use our notation that we've been practicing. So for the mean, we'll notate it using x bar. And then the standard deviation is going to be 22. Right, this one has the greatest variability in the data, as evidenced by the fact that these numbers on this axis have the largest spread. Out of these last two, which one of them are going to have the smallest standard deviation? Well, if we look at this one, this axis only goes to values in the 40s to values in the 60s. This one goes from values that are be below 30 to values that are starting to get in the 80s. So histogram B is going to be the one that's going to have the smaller of the standard deviations. So this one's going to have a mean of 53 and then the standard deviation of 1.8. This last one is going to be the one that's going to have a mean of 53 and the standard deviation of this one then would have to be 10. So we get better at looking at standard deviations for just maybe one particular set of data and being able to internalize what that number means with regard to that data. You just look at data sets and over time you start getting a better sense of what the standard deviation is telling you. For right now, I think in order to help us wrap our head around standard deviation, it's helpful to do it as a way to compare data sets. So what we're seeing is that smaller standard deviations lead to data sets that have smaller variability. Larger standard deviations lead to data sets that have larger variability.